Hey guys, welcome to the channel. Today we have an interesting topic that we'll be covering, guys. So we're gonna be talking about cyclic sort, guys. Before we get into it, man, let me just introduce myself. I'm Genie Coder. I help people master data structures and algorithms, right? I'm saying, we have an awesome community here, and we do a lot of great things here. So if you're all about leveling up your skills and getting better at leak code, go ahead and subscribe to the channel and yeah, join this community that we have here, guys. So yeah, like I said, guys, we're gonna be talking about cyclic sort, right? Cyclic sort is pretty much yet another technique to put in our toolkit, guys, to pretty much be able to um solve a lot of problems, right? I'm saying so it's a good technique to have in your toolkit. So pretty much uh the guide that I've been following, right? The I mentioned this uh link many times on this channel, right? So pretty much this is the link um, that pretty much talks about the 14 patterns that are very common in interviews, right? So this person has conducted many interviews and have, knows a lot about the business, right? So they pretty much came up with this 14 good patterns for you to learn, guys. So this is a very good link. I posted it on a lot of different videos. I mentioned it several times, right? So make sure you go to that page, guys. It's very important, right? So we're gonna be covering today the cyclic sort, right? That section here today, right? You know what I'm saying? So let's quickly read what they have, right? So pretty much what we're gonna do, guys, we're gonna pretty much go through what they have here, right? Content here, talk about it, and then we're also gonna try to code that up, right? And then once we have that video done, right, we're gonna be doing some problem that involves a cyclic sort, right? So that's why I'm doing this first, right? So that people can come to this one and try to do it, right? So yeah. So and try and I'm gonna keep referencing this video and other videos, right? So that people can come here and then kind of learn about about this technique, right? So pretty much cyclic sort guide, they say that it's a pattern describes an interesting approach to deal with problems involving arrays, right? Containing numbers in a given range, right? Okay, so you said the cyclic sort pattern iterates over the array one number at a time. If a number, if a current number you are iterating is not at the correct index, right? They're gonna define what correct index means, right? You swap it with the number at its correct index, right? You could try placing the number in each correct index, but this will produce a time complexity of O of n squared, right? Which is not optimal. Hence the cyclic sort pattern, right? So this pattern, guys, is very good, right? So pretty much the good summary, right? Pretty much if you're given an array, right? And the array, you know what I'm saying, contains n numbers, right? N elements, right? And then n numbers, right? So and uh and the numbers, the range of the numbers, right, are from 1 to n, right? What I'm saying. And so that means if there's n numbers, right? N numbers, and I mean the highest number can be n, right? What I'm saying. Let's say there's like 5 numbers, right? So the highest number in the array is going to be 5, right? So the numbers are going to range from 1 through 5. If there's 6 numbers, the size of the array is 6, right? Numbers are going to be from 1 to 6. That's the range of the numbers. That's pretty much what you're saying, right? So whenever you're kind of given this kind of hint, right? You got an array of size n, and the range of the numbers are from size 1 to n, right? So whenever you're given that, cyclic sort should be the thing that comes up to mind, right? I'm saying by sorting the elements, right? By using cyclic sort, you can do that in linear time, guys, instead of doing it in square time. I'm saying by placing, I'm saying every number, I'm saying yeah, so doing it in a linear fashion, I'm saying. So a lot of problems that may seem difficult first, right? I'm saying uh can be used to pretty much by using cyclic sort, you can really bring down the time complexity, right? So I'm saying that's why cyclic sort is so efficient, right? You could go as well as sorting, or sorting is gonna cost you n log n, I'm saying. I'm saying if you were to use something like merge sort, right? That would, what I'm saying, that would cost you n log n. So a cyclic sort has its benefit, right? I'm saying the numbers, like I said, they range from 1 through n, right? So that's kind of the giveaway whenever they give you that, right? The set of the arrays of size n, and the numbers are from 1 to n, guys. I just want to make sure I clarify that very deeply so you guys understand exactly what I'm trying to say, guys, right? Example is pretty good. So the way that they do it, right? So we get a pointer, right, that points to the starting element, right? And then what you do here, guys, we're gonna iterate through the array. As we're iterating through the array, guys, what we're gonna do, we're ultimately, I'm saying, what we gotta do, we have to put every number in their correct position, right? So that's kind of our job, right? That's how we're gonna end up doing in linear time, right? So number two is not its correct position, right? We know the correct position is determined by the value of the number, right? Minus one, right? Because the array is a zero uh, index, right? Zero base, right? I'm saying it starts from zero. So that's why every number is going to be at its correct position should be, I'm saying, at its value minus one, right? So we're gonna end up sorting the whole array, guys. So one, right? It's the index that should be in the array, right? If the array were to be sorted, right, it should be the first index, right, which is at index zero, right? Because we know the numbers are ranging from one to n, right? So if it was from zero to n minus one, right, then it would have been every number would have been to just be at whatever index of their value, right? I'm saying is, right? So let's say index of one will be or one will be at index one, right? You know what I'm saying? And zero will be at index zero, I'm saying, in that case, right? So for this one is um the numbers that range from one through n, right? There are six numbers, right? So we start with the first number. What we do here, guys, we check two at its correct, so we get two, right? Two, its correct position is um its value minus one, which is index one, right? Which is the second position in the array, right? Which makes sense. And then we see that the number at that second position, right, is not the same number as this number, right? As two, right? Is not the same number, guys, right? You know what I'm saying? So that's why we end up doing a swap here, guys, right? We swap the numbers together. So that we put two, right? That number two that we're referencing right now, right? To its correct position right now. So I'm saying, so we put two exactly where it's supposed to be right there, right? And then we keep doing that, right? And then we check, and then we swap the numbers, right? So now two is in its correct place, right? Now six, right? We're not gonna move forward. We're not, the pointer still stays where it's at, right? We just do a simple swap, right? But the pointer that we're gonna use to iterate through the array, right, stays put, guys, right? Stays put, right? And then what we do here, guys, no, we're still pointing at six, right? You see, in the example, also they did something wrong, guys, right? They left six behind, right? Which is not good, right? So its examples is a little bit wrong, right? They did a little bit of an oopsie, right? Because we're still supposed to be pointing at six, right? And then we see that six is not its correct position, guys, because we see that the value at the last position, right? What I'm saying, which is at index five, right? I'm saying, which is I'm saying, because zero base, right? Remember, that number is not six, right? So we know that that's not right. So we would swap it with the five, right? And then we would put six in the correct position. Then five will come here, right? And then five was in the correct position, right? Five would have been there, right? And then one, it would have switched with one, and one would have been there. And finally, we have the number that's supposed to be at that index, right? The number's there now. That's when we'll eventually move on to the next array, right? We check two, is that correct spot? Then we move forward. And we see that four and three are not the correct position, right? So we swap three to four, three's here, then four's here, and then everything will be in the right spot, guys. So it's as easy as that, guys, right? I'm saying. So it's a very, very good pattern, what I'm saying, like, to learn and be able to do it right. So it tells exactly how to identify a lot of those different pattern, guys. I'm saying, find this particular pattern, right? It involves a sorted array where we give a number of range, right? That's what I say. That's kind of like the dead giveaway, right? The number asks you for a missing duplicate or smallest number, right, in an array, right? In a sorted rotated array, whatever it is, right? So it's a very, very important technique, right? You know what I'm saying? And they also go over the different problems, I'm saying, the different problems that can be solved using that kind of technique, guys. So it's a very good thing that we learned about this pattern. So we can go ahead and code that up really quick, so you guys can understand it better, right? So right now we just press run. So we see that see that's before, right? The before, the array is 3, 2, 1, and after 3, 2, 1. So it's not haven't applied the logic here, right? So we see the array is it's not sorted, right? Unsorted, right? So now our job, guys, we're gonna apply cyclic sort because the array is of size 3 and the number ranges from 1 to 3, right? So this fits perfectly what cyclic sort would look for. I'm saying, so cyclic sort is a very, very efficient way to sort, guys, and it's gonna by knowing how to use cyclic sort, we'll be able to solve a lot of problems, guys. Like find the missing number, like find the smallest missing positive number, right? So that's definitely gonna help us a lot, guys, right? Um, Okay, so now what we're gonna do, guys, let's apply some logic real quick, right? So what we're gonna do, guys, we're gonna need a pointer, right? So let's call this pointer, uh, pointer, the first one, right, 0, right? I'm saying let's call it index, right? And then we're gonna have a while loop, guys, a while loop to pretty much help us in doing the, right? So while the index is less than the array data length, right? While we haven't iterated through all of the numbers in the array, right? What we're gonna do, we're pretty much going to do a correct index, right? Because we need to make sure that we put that number in its correct position, guys, right? All right, so how we're gonna do it, guys? Pretty much we do our array of index, right? Then we index -1, right? Because I told you every number, right? It's pretty much its correct index, right? It's gonna be its value -1, right? So for 1, right? Let's say we at 1, right? Its correct position is going to be 1, right? Let's say we're, I'm saying, -1, which is 0, which is its correct, and this is the place where it should be at, right? So that's why we do the -1, 2, because the array is 0 index, right? So, because I told you every value, every number has its correct position in the array, right? It's cyclic sort, right? I'm saying, thinking, um, its position, it's at index, its correct position is going to be at its value -1, right? So let's say the numbers will range from 0 to n-1, right? It will be a lot simpler. We wouldn't need to do the -1, right? Because we would account for 0, right? Because 0 is at the first index, right? And then everything would have aligned perfectly, right? So since the numbers range from 1 through n, right? And we know that arrays are 0 based, right? So that's why we do to do the -1 to do the proper indexing, right? You know what I'm saying? Okay, so after we do that, guys, what we're gonna do, we're gonna do 2 checks, right? We're gonna check right there, right? Okay, let me zoom in real quick. Oh, yeah. All right, so now what we're gonna do, guys, we're gonna do a simple check, right? The check is gonna be very simple, right? So we're gonna do if the array, right, at correct index, right, right, if that's not equal the to that number, right? If it's not equal to, so the number at if the number at the correct position, right? I'm saying is not equal to that number, right? That I'm at right now, right? If it's not, what we're gonna do, guys, we're gonna do a swap, guys, right? So a swap between the two, right? So we do array of index, um, right? We store that, and then we overwrite the thing at the index, right? With the correct index, and yep, and then the correct index, right? Just do a simple swap, guys. Literally what we're doing right there, right? I'm saying, so since the number, so we get the correct position, right? So we get the correct index, right? We check, right? Does the number at that position, right? I'm saying if it does not equal to that number, right? Then we do a swap, guys. So make sure that you guys understand, right? So we did the thing that we do it here, right? That's the same thing. So we check, right? We did 2, right? 2, its correct index should be at its value, right? -1, which is index 1, right? I'm saying, and we saw that is the number at that position 1, right? Does if it does not equal to 2, right? See, I'm saying if it's not the correct number that's there, right? So we do a swap. That's why we end up doing. We switch the 2 with the 6, right? You see exactly what we're doing here, guys, right? Make sure you guys. So we do. It's not that correct number, and then we just do that, right? Do that check right there, guys, right? Right. And then yeah. And after we do that, guys, okay, we don't move forward yet, right? I'm saying, and then if it's not, so it's two checks, right? So if it's does not equal that, we do a swap, right? I'm saying, and if it is that correct number that's there, right, we do index plus plus, guys, right? Right. And that's when we move forward. So we don't move forward, right? See, I didn't do index plus plus here, guys, because that's not the correct number that's there. If it's after we do the swap, right? I'm saying if it might still have a number that's not at its correct position, right? So that's why we stay here, guys. Let's press run code. See now, after we do that, guys, the array is sorted, guys. So you see how efficient cyclic sorting is, guys, and how it's going to help us in solving a lot of problems, right? So if you guys like this video, guys, make sure to give me a like. If you find it helpful, I would appreciate, give me a like and, yeah, subscribe to the channel if you're new here. And, yeah, guys, I want to thank you guys for watching, and I'll see you guys in the next one.